Welcome everyone to an episode of Clearspot. Let's imagine this. You're running 300 megawatts solar plus storage portfolio, and your dashboard are saying everything is fine. But in reality, you're losing 3 up to 5% of your annual revenue. And this can happen every single year. Not because your analytics are wrong, it's just because sometimes they are blind to the right failures. No alarms or red flags, just uncaptured yield. So our guest today, it's an interesting profile. So we have Abhishek Parikh, technical lead for solar installer and storage operational analytics at EDF Power Solution in North America. So he builds the system that actually tell the enterprise what is actually happening across hundreds of megas, if not gigawatts, in real time. So in simple terms, when the fleet underperforms by even a fraction of a percentage, his teams has to find out what is wrong, why, and even fast. So welcome, Abhishek.
Thanks, Antonio. Yep.
My
Thank you for
pleasure.
having me.
It's my pleasure. So before we start, let's just to give some context to before you introduce yourself, to give some context to whoever is gonna watch this episode, since it might take 1 hour. So in this episode, we're gonna break down 3 things that every asset manager or lead needs to get right in the next at least 24 months. So first of all will be how bad data quietly can destroy IRR on large portfolios. Second will be why tools that work at 100 megawatts might fail at to a gigawatt scale. And third, what really takes to trust AI and automation in day-to-day operations. So basically for whoever can own performance, revenue, or even risk on a solar or storage fleet. So basically this conversation really will give you the language, the framework, and all the example you can use with your team starting from this quarter. So thank you, Abhishek. So yeah, if you want to start basically introducing yourself, telling us more about your experience, um, yeah, great
Sure.
to have you.
Yeah. Thanks, Antonio, again. So I've been a technical lead at EDF since this April, and I've been working with the company for over last 4.5 years now. My experience started at Enril, where I was a grad intern, and that's what got me into like solar. And I worked at NextEra and DNV before EDF. So yeah, uh, it has been like a fun ride. I used to work in pre-construction at NextEra, and then DNV, it was more like independent engineering, working on all sorts of like cool projects over there. And at EDF, I've been focused on operational assessments of the portfolio.
It's great. So today, if we start, do you think what do you think is like running a large solar portfolio? How does it look like for everyone who is, because just to give you some context, there are some people maybe watching, they might have installed some kilowatts, they're on their residential, they might monitor up to 10, 20 megawatts, but it's really unusual and uncommon to monitor up to gigawatts, right? So
Yeah.
if you just can, for someone who never might even never be exposed to this size, how does it look like? Uh,
So I think like when we talk about performance, it can mean a lot of different things to a lot of different people. Um, and when you have a portfolio of like, a couple of gigawatts or more, some problems can be clubbed into like common group. Some problems are very project specific. And so performance can mean like financial performance, technical performance, like how is the availability of a certain project looking like. Even availability can be different, right? Like from project to project, and the definition changes. As for example, if you talk with a O&M team, availability for them may be very different than people who are doing energy assessments. And so I think operating like a big portfolio is quite complex. Um, yeah. So like I said, there's a lot of moving pieces in there. Um, and if we solely talk about like energy, uh, I, I don't think like it gets any easier compared to like having like a small portfolio. In fact, like the challenges actually multiply as you have more and more plants. And with automation, I think some of these challenges can be assuaged, but overall, yeah, it it is like pretty complicated.
Yeah, no, for sure. So what do you think is right now the gap between a portfolio, what a portfolio what it looks like on a dashboard, and what actually looks like in reality? So in terms of gap, the real gap, which again in your position, I think you're really daily
Yeah.
you see.
So yeah, like dashboard when we if you think about like a dashboard which may be showing you real-time performance uh, of a project or like a portfolio, uh, that may be solely focused on how much energy the plant is producing versus how much it should be producing, right? Like a simple comparison. And let's say if there's a huge gap in there, it may not mean that that the project is actually doing really bad financially. Um, and everything boils down to like the incentives of behind like a project's operation. So if a project is, let's say, it has huge availability issues, but the project is like under some kind of capacity contract, it may not be impacted at all. So uh, I feel like the most important thing to keep in mind is when you're looking at a portfolio, try to take some time in understanding what is making the projects or like what is making the portfolio tick in a way. And I think the performance really kind of then becomes important once you have that context.
Okay. Yeah, so no, I understand your perspective. So basically, I mean, we see that even the standard from OM asset owner, I mean, it didn't change the last years, but actually, in terms of since the performance is and the real market is changing, the financials, I mean, the structural from curtailment to negative prices, they are changing. I think even KPI are adapting and contracts slowly they should adjust accordingly. Because maybe, yeah, I agree with you. Sometimes contractually wise, they're not always correlated. The performance is no longer correlated. Availability doesn't mean your site is producing as much. Doesn't mean
Correct.
you're not losing dollars. So for sure, even the OM, the contracts, the speed, I mean, should be adjusted to, and adapted to this new environment market. So do you think that the tools built 10 years ago, because I expect, I mean, in your experience, you have seen portfolio sites connect to the traditional SCADA, to the traditional system, the basic, right? The standard, I will say, previously, 20 years ago, solar is something like it's been old right now, even if it's changing, adapting in terms of tech,
Mhm.
technology of the panel inverter. But do you think the tools of 10 years ago are now structurally sufficient or maybe are insufficient for the a portfolio and all the challenge in 2026?
I think that's a good question. I don't think that the we should like just think about like the tools. We should think about the entire infrastructure of how the project gets designed, like from origination, how it goes through like through all the vetting of pre-construction steps, how it actually gets built, and then how it actually gets operated, right? So that whole journey, the plant itself sees so many variation of drawings and design parameters and all those things that by the time that the project is operational, like um, lots have changed, and all the rich metadata that was relevant for the project's life is now lost. So SCADA or like the tools that we have right now, which are built to give you which essentially like solve the telemetry for you. They're like I think a part of a bigger infrastructure that I'm referring to, and everything I feel like needs to be adapted so that we have this one cohesive uh, map of the metadata and the tools that you deploy, to get the operational data from the projects. Um, so and what I mean by that is the SCADA that we have today has really rich information available, but a lot of times, for example, like you'll see that the mappings of these tags that you have in the SCADA are kind of messed up. And that is because there was no communication between the design or like the people who actually constructed the plant and the people who did the SCADA design. Uh, so yeah, like in a way, my point is, I think the SCADA is there. It needs to evolve, but I think the bigger problem is the lack of um, communication between like different steps in the entire journey.
Yeah, you're saying from an asset lifecycle perspective, actually, the system is broken just because the designing it lives in a silo from designing up to commissioning. The commissioning, maybe you have 1 year of once you plug everything, you under monitoring and management of the
Yes.
construction company. You work with a construction, so you're about this, but and after you start having OM contracts, you might switch from one to up to two, three providers during the asset lifespan. So the question is, yeah, how can you, assuming all the variables which are affecting the site during this period, because we are talking about, okay, even the sensor might need recalibration, assets might
Exactly.
failing, hotspot might rising. So the thing is, in the meantime, 4 or 5 people work in different boxes, mostly in Excel, because I mean, even if they have their own, and we see that, and so I get your point. I think I think the industry needs to be more data aware about what they are doing because they are doing at the end they invest. We see that if you invest in a drone inspection, your provider is having that information, but you should even have it once you invest in that inspection. Same for other specific activity. But I get your point. So what do you think is the most common data quality failure on a large solar storage portfolio, and how do you think they compound over time and up? Well, actually, because I'll give you an example. SCADA, for instance, that doesn't detect a lot of things. 5-10% failure on the performance by inverter string, those things go unnoticed, right? So
Yeah.
basically, you start detecting as a certain failure of the asset of the component itself, and actually you need to replace it. Now, once you detect, maybe it's too late, so you lost 10,
Yeah.
100K based on the relevancy of the component will actually fail because if it's a main inverter, for sure it can really affects a
Yeah.
lot financially the portfolio. So what do you think are the most common data quality failures in this
No,
sense?
I think like all these signals that you receive from a operational plant all suffer from some kind of data quality issues, right? So, and I'll get to that in a second. But there's like another data that suffers from like a huge quality issue, and that is like plant metadata. Um, you'll be surprised that a lot of operational plants, the metadata that one would have in like a, let's say, PVSys or some equivalent model, or like even the as-built drawings, that could be very different. So the as-builts may be saying that this particular inverter block has, let's say, X% megawatt DC on it, whereas if you go out there, you may find it to be like 0.97%, sorry, 0.97x of it. And yes, like it is there. Like I have seen like in instances where um in my like entire experience, I've seen that happening. Also, when the plant gets commissioned, there's another kind of data quality issue that you'll see, and that is the way the plant was commissioned in the first place may actually have some biases built in. Like, for example, was the plant commissioned with proper tracking parameters? A lot of times, what happens is in the first few months, the trackers were set up with certain settings, and those never get like kind of adjusted to actually reflect the as-builts. So those are kind of like the data quality issues that you may see um, right from the beginning. Coming back to like the like like doing the routine operations of the plant, I, I feel like data quality is a very broad topic, and one of the first things I always ask is where am I getting the data from? For example, if you are looking at inverters temperature, for example, where is that temperature really being read? If you are looking at inverters DC power input, is that DC power that you are seeing in the SCADA, is it something that the inverter calculated based on the current and voltage? Or was it like where is the current being measured, right? Like in calculating that DC power. So I think all these questions are very important in order to understand data quality, because data quality is not just saying, hey, this is faulty data, this is out of range, or this is stale data. No, I think those are like important, but they are not sufficient. You're like one always needs to ask about, if I'm using a measurement, is it being actually measured? Is it being calculated by some system in the entire pipeline? Is it averaged out over certain minutes? Is it an actual reading, or was it like an average of like, let's say every 5 minutes? Um, for example, I deal with a lot of fault events in best monitoring, and yeah, when you are like doing availability calculations for best, you want to use the event data and not like any kind of resample data. Um, so so I think that's one thing to kind of keep in mind. And sorry if I'm digressing from your question about data quality itself, but my point is data quality is a very broad um, topic, and there's a lot of dimensions out there
I don't know,
to it.
completely, completely. Especially because at the end they are mostly correlated from an hardware, from sensors. Actually,
Yeah,
those data are not coming. It's not digital data. We take them, we analyze, and after maybe
yeah,
the problem can be manipulation, like in AI as
e-
well. Maybe
e-
if you work with
e-
AI, but I get your point. I mean, the context and all the question we should even ask before we look at the data should be, okay, are those reliable from a source standpoint? Do we have
exactly.
context enough? No, I get your point. I mean, it's not simple for sure. Um,
Yes,
yeah, I mean, I get because people should have even experience with the hardware itself. Sensor calibration, different type of sensor, different type of like even providers, which sometimes are different. People are not that expert, especially when you monitor across portfolio. And we see a lot of people, especially right now, oil and gas company. They start investing in solar. The reality, they don't have people expert in DC issue first. Second, they don't have experts in sensor, solar
exactly.
sensor, and all the correlate to the weather. So a radiant sensor. So for sure, I mean, I think the sensor itself could be on a separate episode in terms of saying, I mean,
Yep.
PR
So,
people qualified. Yeah,
yeah,
enough.
I feel like, yeah, the data quality question has always been like a very important one for us, like for the industry in general. Um, and actually, I did give a talk at ACB 2024 in Phoenix on this very topic about like data quality. Um, I can throw one more example in there because this I think is very important, but also very easy to miss. Is for all the operational assessments that we do, right? We always use some kind of meter data. Typically, it's the plant meter data. And what I realized was these plant meters that we have, they actually can be programmed to uh, include certain kind of losses, include or exclude certain kind of losses. So it's always like important to keep in mind uh, that the readings that you are using are they having some kind of losses or not? So yeah, like just one more kind of interesting thing to keep in mind.
I don't know, completely. I mean, I think it's interesting. We can come back. I think data. I mean, the impact of data quality, I think, will come up,
Yep.
and even during the analysis. But so, how do you think? Like, how do SCADA hierarchies normally that do not match physical site configuration, which I think we see that happens. So, normally corrupt the performance metrics. Does it happen to you? They
Always.
don't SCADA hierarchy a lot, right?
Yes. Uh, it's very rare to have like a plant which has been operating for 5 years and did not have any SCADA issues. It's very rare, almost impossible, I would say. So, and yeah, I think that's where like it is important. I feel like AI can help in this aspect really well because now you can build so many uh, cross checks and correlations, and it in a way I think it will become easy at a point to catch um, issues like this. Like if you have, let's say, a signal which is like strange, but like, as a human, you may take like, some minutes, maybe some time to detect what kind of issue that it may have. I think AI will start recognizing these kind of anomalies relatively quickly.
I don't know. We see that. I mean, when we plug with SCADA, doesn't matter where. I mean, for sure depends on the setup of the specific individual site or portfolio. But normally, yeah, the system fails. The reality, the difference is once you never done it. If you have to do it manually, you don't detect this
Yeah.
loss. If you have a pipeline in place, if you have, automated monitoring system, or even a proactive tool, or invest in agentic. We do agentic, which is, I mean, I think is the next step in terms of full automation of the end-to-end. Not just in terms of analytics, it will be in terms of, correction mechanism,
Yep.
in terms of a specific failure, or even as well as we just said, you need to run. I mean, right now, an agent, the reality can perform this quality validation, or even about the SCADA, the latency. And I think there are a lot of things, as we mentioned, there are millions of data points. So I think humanly is not possible, even for the best engineer, to go through each Excel line, take the data log, extract, manipulate. They can do it. It's possible to do it, maybe,
But
but I
but
don't think it
yes,
makes sense doing it, right?
exactly. Is
So,
there like do you have that kind of deep pockets like to spend like, on O&M and like, go out there
no, and
manually?
this is the thing. The problem is still allocation stays at at investment. So once you
Yep.
plan, and this is the point. You had specific, even on the financial planning, you have some expectation which have been completely affected and drastically changed during the life across all the markets I see, from California, Texas, Spain. Actually, all the previous financial estimation of the portfolio, whether it's the asset owner invests over 25 years, the portfolio is underperforming. There are negative prices. There are curtailment events. There is more zoning accumulation. So, long story short, you are losing. So if you don't do this, because it will be 10%. Normally, I think it's the OM cost is 10% of OPEX allocation of the initial investment year on yearly base, which means the margin are quite thin. They're really like they're not enough to invest in new things if you don't have an approach in order to prevent things to fail. So you don't need to invest in the new, you know, inverter, or once it fails, or you can anticipate. So meaning changing the approach, I will say, which for sure it takes more time. But in terms of data quality, when did you see that actually really became a financial risk, not just an engineering inconvenience? But really say, okay, we saw that by having this issue, or once we acquired this portfolio, actually by not monitoring on this, they miss all of this issue, were unnoticed, and they lost this amount of dollars, which I think makes sense to talk more about dollars in 2026 than about the component fail. I don't think any people care anymore about this individual component, as if it's not correlated to the financial impact of the component itself, right?
Yeah, I mean, so every person who's kind of doing any energy assessment or doing operational assessment needs to take it forward, take that energy assessment and connect it with some dollar amount or some financial KPI. Only then you realize, okay, what's the actual value you are losing, or you can recover in fixing certain kind of issues. I think without that, there's no way you can understand like if what you're doing is just like a technical assessment, or is it like also a big financial um, uh, is it having like financial implication? So I think to answer your question, when did I realize? Well, I always like to talk with people who manage these assets. I like to understand what's their priority and how much production means in reality from these plants. I think that's where I started understanding, okay, uh, what it means to have like bad data quality, which leads to some kind of blind spots, and that can eventually like you're essentially like losing money in a way.
I know completely. I mean, I think SCADA unfortunately right now doesn't tell you the dollar loss. It
No.
might tell you actually that inverter, is failing, or but the next step I would say it's in order to be, have a corrective, effective decision and not affect the P&L. I think be oriented, driven by financial losses could be a good metric to move forward in the OM department,
Y- Yeah, so
right?
I think SCADA gets you that data, right? Like it does not
Yeah, the
have any
data, yes, but
insights.
doesn't tell you actually you're losing
Exactly.
30K.
Yeah.
Yeah. Imagine you manage gigawatts. On a gigawatt scale, you're monitoring 1,000 of string inverters,
Yep.
million of panels on a gigawatt scale. The question is, how do you prioritize? You have 10 events happening. How do you prioritize? You have two teams, three, five different locations. How do you prioritize which location? Outside of the technical, I know, I mean, if you have system in place, it's great. But I'm talking for whoever doesn't have those system in place, whoever is still relying, maybe at a gigawatt scale, they start early investing in these tools. How do you
Still,
prioritize what
still,
is worth
Antonio,
prioritize?
you may be surprised actually. A lot of people, I do have like, industry connections who work with fairly big companies. You may be surprised. Not everyone has that kind of system where they connect energy impact to dollar impact. Now, if your portfolio is running, let's say, 10% lower than expected, then yes, you will have enough signals coming at you, which would say, hey, there's something wrong. But monitoring each and every project down to the string level, and then having a good insight into like, oh, my DC health is not that great in this 3 of the 10 projects that I'm running. Not every company has that, and that's where I feel like advanced analytics in a way like has a big role to play. That if it can showcase that hey, you are running this problem, and then in a way, of course, it has to connect with the dollar impact as well. Uh, yeah, like my point being, very very few players in the industry have that kind of approach right now, and also like the question is, do we have the right incentives in the right place, right? Like um, that's another question.
Yeah, I think it's a big point completely. I mean, I know the big beautiful bill. I mean, things change in the last years, actually in US. I mean, the rest of the world, I think China is leading in terms of manufacturing production with certain intent. Once we talk about, for sure, a push to innovate, readjust, things are changing globally. Now, I don't want to you know,
Yeah.
change topic, but for sure, I think politics and even financial stimulus align to, for sure, I mean, an
Y-
adjustment. Right now, people are investing in
Yes.
US, they're pushing to create their own inverter. It's not easy. 90% production is Chinese, so I mean we cannot change
Yeah.
overnight procurement from where it's coming and adjusting to the price. But I think for sure this will play a role in terms of uh, I mean pushing a market to a dimension where actually the positive things if we talk about AI, all the other industry, you don't have assets where actually you can correlate the value of data with a financial cost, which I think is great because I mean, for even someone to say what is AI, you don't need to know what is AI. You need just to know how by using AI simply just more intelligence. Now it's becoming even action decision. Before was mostly analytics. Now with the agentic and more, fully
Yep.
automated is moving up to full orchestration, or what we see with our agentic orchestration system. But my point is yeah, the industry needs to change, even if it might be enablement, starting from enablement, because everyone should be aware of what he's doing, because his job, 90% of the job we see, I'm not talking about physical replacement, which for sure, I mean, you need on-site engineer or electrician, but 90% of things done on the back end, we automate 70% from EPC, OM, asset management. So the reality is tomorrow in your company I'm not saying in any company, restructuring costs is the first thing people want to. CEO, I talk with CEO, the first thing they can control cost. This is the thing. On the revenue, you don't know how much you can produce, you can increase. They're not that flexible. On the cost, when they can compress. So why I'm saying that, just to keep everyone listening, saying, yeah, it's a good time to be ready, even if you're not, and I had a great even previous conversation with people saying, from electrical engineering now, and I see every day more profile coming from a technical background, moving, even learning about data science, Python, which at the end, I mean, with solar you work with specific data. Maybe it's a different type of the voltage. It's not the usual one for data science, but still it's data, still needs to be analyzed. And I repeat, the thing in which you are aware is not all the data normally have a financial consequence if you have a misinterpretation, if you don't analyze properly fast enough. So I think that it's huge could be a good push for people to look into any type of at least in this direction. So if we move to, since now we're talking about performance, why do you think why availability metrics can look healthy? And maybe you have seen you work with across different companies, while a portfolio silently is losing 6% of annual revenue, which I think sometime right now, maybe people are neither aware of this because they still rely on the standard generic PR with the standard generic system. But why do you think this can happen in the average portfolio?
Um, so first of all, I think availability it's a very subjective thing to talk about, and as everyone knows, its definition changes from for different teams. Uh, for example, if you if I'm an O&M guy, if there are a couple of inverters with uh, you know, some issues that I cannot do anything about, I'm waiting for the parts to arrive. And I know that, okay, for next 3 months, I'm not going to get these parts. So the question is it on me? Is it on the supplier? Is it on the like who on whose clock is it? That is the question. And so what I may do is I may elect to just talk with my asset manager, my asset management team, and say, hey, I'm not going to get this part for next 2 months. So you need to exclude those inverter hours out of my calculation because it's not on me. And this is where it becomes very interesting um, to think about who is really paying for this, because it is at the end of the day definitely impacting the production. So all of a sudden, now you have lower production, but the availability was kind of adjusted because it was something that we could not do anything about. Now it is a different discussion where somebody may say like, why didn't you ask the supplier for this, and like why it should be the supplier who should be responsible. But maybe they are like having their own problems of like supply chain issues with all sorts of global problems that we are dealing with, right? So this is where I feel like this is a very simple example of why availability may not correlate with production always. I think some of the other salient points I can bring out are, for example, if your availability is based on, let's say, the median performing inverter, right? Like, so all the inverters are performing. Your method takes the median of all the operational inverters. What happens if all the inverters had 1% string outages, for example, right? Now, all of a sudden, your baseline has reduced a bit. And sorry, can you hear me? Yeah, there was a truck rolling by. Uh, so all of a sudden now your baseline has reduced by 1%, and your availability is now, really good, but you're still like losing that 1% from all the inverters, right? So same thing can be said for trackers. Uh, Degradation, it is even more subtle than everything else, and it is real. So let's say if the plant has experienced crazy bad degradation for 3 years now, but all the inverters are running up and fine, all the LBDs are working fine. Yeah, yeah, the plant is available 100%, but your production is really uh, marred by the aggravated degradation. So in that case, if you did not detect degradation earlier, you're now dealing with consequences of that. So yeah, it's kind of a I think it's a good question, and there are so many versions of it where availability sometimes is great, but the production is not. And um, yeah, I don't know if I if I
No, no, no,
answered
no,
enough,
yeah.
but
I think it's the question actually touched a structural point, which I think the problem of, I mean, availability, if, as you mentioned, the main problem here, I think there are layers, which are contractual layers, and
right,
which actually you set once you have a contract with the OM, once you set even when they should be responsible and which specific, who will be liable of this, who will pay for this, and what is the level of what I see looking at different contracts normally is in the interest of the OM to keep it gray, because you don't want to be over specifying things. This I'm talking from a contractual responsibility. From an availability and performance standpoint, I think right now the underperformance has become so evident that there is a huge, from what we see, a huge gap from availability and performance, because a site can be available but can still underperforming. So just saying, make sure my site is available 96, 7% of the time is no longer enough, because if it's available 96% of the time, but it's still there is solid accumulation, you're still not having the best practice. I mean, mostly it's you don't know, you don't run any thermography, you don't know if there is an hotspot, you don't replace any panel affecting. Same for diodes. So inverter string performance you don't monitor to understand if my point is all these aspects which have never been mentioned. I don't expect any of our OM contracts to look into the specific things to make sure that the solid accumulation doesn't reach a specific threshold to say let's trigger a proactive cleaning event. So my point is just, since the contract at the end defines what the company should do, at least on the OM side, and the OM is who is in charge ideally to make sure that the plant runs smoothly, because things were set 25 years ago. And I think especially on the residential, which is different from the utility, but they sold solar, they're still selling solar, saying you don't need to do anything. You just plug and play, 25 years, we'll go with it. And this is a sad reality. I'm receiving emails from people still selling, I don't know to ask, maybe not the best saves, but with this storytelling, which converted in 2026, you have enough data over years proving that all the portfolio I see, it's rare that I don't see portfolio underperforming even 2%, 1%. It's rare to see a state-of-the-art sensor, proactive measure system, just because it requires investment, which is at the beginning. It's more should be more in the capex section for me than OpEx. And you to make even the OpEx, over 25 years, more sustainable. But
Yeah.
who do you think could be this even as structural? Because for me, I think it's more a structural things. Because in 2026, how is possible? Everyone is working and no one is looking at performance, even because they see that. But unfortunately, the system, from a contractual standpoint, is still stuck in not taking, because even though they are not, they don't have incentive. We talk about incentive. They don't have incentive even to optimize this performance.
Yeah, and
Sometime.
honestly, like to be fair, so I work with a lot of site people. I'm really actually fortunate that I get to learn a lot of stuff from them. And what I'm seeing is, um, on one hand, we are dealing with more issues, but also on the other hand, I think the industry is shrinking the O&M budget more and more day by day. And whether it's a reflection on how projects get bid and how they get operated, like how, like what's the cash flow coming from. I think this is kind of slightly beyond my scope of understanding, but what I do realize is O&M is getting squeezed a lot. And to the point, like I was just like thinking about how many people were operating a 500 megawatt coal plant or natural gas power plant. I'm not taking nuclear into account because it's a very different technology. But if you look at those numbers, right, like how many people per 100 megawatts of power production was there like 20, 25 years back, that has shrunk a lot, almost like by an order of magnitude, if I'm not wrong. And now, if we expect that kind of same reliability, sure, like the technology is very different. Running a turbine is very complicated in a lot of ways. There's a lot of things going on, but still, like I think like there's definitely some correlation between like how many people you had before and now.
I know completely. For me, there are two dimensions. After I think we can continue on the performance, but the first is the structural dimension where actually the market, whoever invests in a plant on 25 years with certain variables and conditioner to have a certain
Yeah,
return investment, PPA condition, market prices, performance of the site, those conditions are no longer the same because the market is no longer the same. So for me, this is one. The second is, so actually for sure I push you on what you can control, which I repeat. I think it's still the cost and the OM is what the asset owner is still kind of a control on continuously on the lifespan of the asset. And after the second is right now you have ideally, I'm not want to say in a bad way, but just in a way because let's keep relevant information. The industry is still lacking 100,000 people, if no more, of specific electrician, competent people in DC solar, just in US. So what I'm saying is the industry still, even if the company are suppressing individually, the industry will still need people. So
for sure.
for in an ideal world, for me, if before you used to need 3 people, example, now you can have 1 person and half on site. For sure, on site will always be required, but if you can do things in a more proactive way, and 90% of the things, the back end, the boring, I'm not talking if you're an asset manager, even that case, contractual, legal.
Right.
And same on the performance. Tomorrow, with a better system, you can fix 90%, but for sure, it's something which required a pre-investment, which you don't wake up after when the site, because when the site is underperforming, if you're an asset owner, you need to resell after 5 years, is your objective. You're losing enterprise, like let's call on the deal, but an enterprise value, equity value. So at the end, that loss could have been fixed and anticipated
Earlier
by
on.
pre-investing. So the reality is, the problem is, I think solar is built a lot on financial, on paper, on Excel at the beginning. And sometimes I think that highly technical awareness, and right now we have enough information to make, to be really competent
The,
when you make one, you make a decision because you
yes.
are backed by data. You can say, I know my site will underperform for 20 years. It's better invest right now in CapEx, which is even, allow me to detach from the OpEx, rather than relying, losing money, keep losing money, which will be a lot on 100 megawatts. You can lose 2, 3 million. I mean, these are numbers. These are the good things of solar. You see the performance. How much is 5% of performance yearly? It's a lot of money. So
For sure.
the problem is people they cannot think. My point is, let's do an reallocation. You want to invest some, you are losing 5%. If tomorrow you can recover 5%, invest 20% of that. 1 year, you save money for 25,
Yeah,
ideally,
I definitely, I
financially
think I
wise.
see your point. Yep,
You
for
know,
sure. And I think that these are like good points actually that we like, yeah, as an industry need to think about. Like, where are we going with this? Honestly, like, yeah, how the projects are being financed and operated.
I don't know because I know portfolio they're shutting up. They're waiting for BAS. Other portfolio reselling. I mean, your own company right
Yep,
now has been sold to another
yep,
private equity huge fund. The reality finance at the end when they will buy, they will not buy because the site was nice. They will buy for the financial performance. They buy a financial
yep,
asset. They don't care. They care about how much this money are making objectively. Maybe
yep.
people in energy, they care about energy. But people buying the asset, selling it, they care a lot
100%.
about
Yeah,
the financials. So
yep.
going back to the performance, so I think just to catch up on some other aspects. So what do you think a good performance look like on 100 megawatt versus 1 gigawatt? And what does the approach fundamentally change, you think, at this true scale? For who is watching at 50 megawatts and who is watching in the order of 500 gigawatt scale?
Uh, I think I'll answer the second part to the question first. Uh, I'll answer the second part of the question first. I don't think that everything scales up very easily from, like, let's say 200 megawatt portfolio to a 2 gigawatt portfolio, or 4 gigawatt portfolio. Some of the analytics I think scales up very nicely. Like, for example, if you had built like a data pipeline to give you actual performance ratios, or if you had some AI agent developed to provide you DC health report, I think these things will scale up very nicely. So a lot of analytics, I think, scales up very nicely. But in terms of certain challenges, um, like, for example, like plant metadata, right? I still think, um, while we feel like, yeah, AI can help us a lot, and it does in a lot of ways, you still need to kind of talk with, like, multiple teams which were involved in design and construction of the plant, and then eventually, like, with the people who operate these plants. And you need to talk with them to make sure that you are really knowing the plant's metadata. So it doesn't just mean like how many panels or that, like, even, for example, terrain, right? I know the energy modeling world right now is focused on terrain a lot, because a lot of projects these days are being built uh, in places with a lot of undulations in the ground. One of the questions I have is, when we do that kind of modeling before the project is constructed, is that terrain really the way we modeled it, like once the project is built, right? So that's something I feel like those things will still be not very easy to scale up when you move from 200 megawatt to 2 gigawatt. Each project will be kind of a new challenge in a way, and you'll have to, like, spend time on it. Also, I think, like, contracts change from project to project, and so yeah, at a portfolio level, you may have a nice dashboard which can show you the performance of all the projects and compare it with, like, among each other, uh, among themselves. But when it comes to contract, yeah, like each project has its own contracts to maintain, and you may still like need to build custom custom stuff for each project.
Yeah, but it's, I mean, I think the only thing is should be, I think either 101 gigawatts. It's just you add more complexity, you add more data, you add more problem. Which if you didn't build the infrastructure, the on a first layer from data
Yeah,
governance, acquisition, data quality, I think you are gonna build on issue, and potential problems will compound and make just more a mess. Everything else
exactly.
more complex the operation, more problems, problematic the analytics. So I think this makes sense. So let's focus right now on another topic, which I think it's really interesting. You have exposure. You're in California. You have I think will be really interesting for whoever is watching. So on the hybrid asset, so when solar meets storage, what makes you think solar storage operationally harder than solar only? Not only commercial, but from a data and monitoring standpoint.
Um, yeah, I think in some ways they're very different, right? Like um, solar is is just like, kind of any other power plant in the sense you have some input in some input like, and it produces power. So essentially in solar's case, you really don't control the input. What you do control is how the plant is operating and how much essentially it can produce. Storage, on the other hand, is very different because now it's a decision. It's not a resource in the sense you're deciding whether you want to charge the storage or you don't want to charge the storage, or you want to discharge the storage or you don't want to discharge the storage. So it's a decision both on the input side and the output side. Um, so yeah, fundamentally they are like very different. And from a data standpoint, I think with storage, um, you are essentially just dealing with uh, a very different technology, right? So if you have a solar plus storage um, asset, first of all, you want to understand uh, how is the solar part of the plant being valued versus the storage. Because uh, let's say, for example, like if they are co-located, that may be very different than a hybrid power plant, for example. So for people who may not know the difference between co-located versus hybrid, a co-located solar plus storage um, would be like two plants but existing in the same location, and they both will be receiving their own different set points from the operator, versus like a hybrid power plant will be just acting as a one power plant and it's going to receive one set point. So even like, yeah, these kind of like subtle contracts, a difference in like, structure can lead to like a lot of complications in analyzing the operations of the power plant, because now in one case you have two set points and you want to keep that in mind versus just having one set point. And so I don't know if I like really answered your question very well, but e- essentially they both are very different technologies, and it's not like solar where you are just trying to understand megawatt hours, like how much you should have produced and how much you produced in reality, and like kind of explain the gap using the uh, issues that the site may have, like trackers, inverters, DCLs, for example. With storage, it's also like you want to first of all understand the 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 decision of charging or not charging, and that has to be clear.
Yeah, I mean, I think the main thing is since the main purpose of the device is to actually allow the portfolio to, either accumulate to charge, discharge, ideally later to maximize the performance of the portfolio and the potential
Exactly.
of the asset itself. So the thing in the picture is not just, meanwhile, the solar needs to produce, the job is simple. The battery, the complexity come from, okay, I need to charge, discharge. So basically, I need to understand from the grid what's going on. Because sometimes even curtailment event can come from the grid side, which
Yep.
is more technical curtailment versus commercial, or when it's your decision to actually charge and discharge. So what I'm trying to say is I understand it's a more complex hardware where the life of the assets actually becomes from the condition of the others, which is the grid, the solar, plus the for sure, I mean the state of the battery itself. And depends
And
even on the type of battery, which right now they're changing. I'm seeing a lot of type of different battery, not just on lithium, but really different type of technology right now being used. Some are
yeah,
great. I mean, but I get your point. So how do you normally build a valid expected versus actual performance baseline when dispatch profile change every day? Especially in California, I know it's quite crazy in terms of grid. Queso, it's quite hectic as a grid. It's not an easy one, I expect too. So
I think it is hard, honestly. Um, it's a mixture, unlike solar. I think the question you asked, um, storage is kind of a mixture of a lot of things. It's markets, it's how you are operate, like how, who's maintaining the storage, um, who is controlling the storage, and then like yeah, the performance analytics. So there's like a lot of like layers in there. Versus like solar, it's yeah, who's maintaining the asset, and then all you need to do is like have a clear understanding of the resource and the plant's metadata. I mean, with storage, you really want to ask different questions, unlike solar. With storage, you want to ask, um, could the system have done what if it was asked to do something? That's the first question. And the second question is, was it asked to do what uh, it should have been asked? And the first one is more like O&M. The second part of this is more on the markets slash the controller of the storage. And yeah, so I think it's a tough question to answer straight away for like in a generic way. But one thing that I think everybody can kind of include in their analysis uh, is is to always bring in the solar piece if it's a solar plus storage system. Excuse me. The reason is solar does impact storage uh, by a big margin. For example, if you are um, if you are doing assessment of how your storage did compared to what it was asked to do over like last week, and let's say it did poorly, but guess what? Your assessment did not take into account the inverter, which was down from the solar side, so it was producing actually less energy, and hence the storage piece was not getting enough charged uh, by the end of the charging window, as an example, right? So I think there's a lot of moving pieces over here, um, and yeah, the answer is not like a straightforward one over here. Like
yeah,
you
you're
really
saying that
want
a lot
to
of variables. The most important thing is you focus on the main assets, which is the solar, because it's the
maintenance,
one
and
which
yes,
should optimize. Actually, the objective
y-
is of batteries optimize the performance of the solar portfolio. So I get your point. So in terms of at what point does battery degradation you think start distorting your solar performance numbers? How do you detect if you I don't know if you experience that in any BESS.
so um we have been operating like a decent sized portfolio, and the I think the degradation piece is, I think it's not the biggest piece of concern right now. That's the cell degradation. I think the bigger piece is always like how do you balance these huge systems, right? Like it's one thing to balance a a BESS with, um, let's say 10,000 cells versus now you have 500,000 cells, right? So I think that's where like the bigger challenge is. And also, um, I think the second piece I feel is a problem, especially like with DC coupled systems, is you have BESS, which is built by company X. You have DC-DC converters, which is built by company Y, and then the inverters built by company Z. And all these three things have to talk with each other in sync. And yeah, sometimes like it is almost impossible to get them in order. Like uh, it would just like prevent a smooth operation sometimes. So uh, I think that can also like lead to a bit of a challenge. So I think yeah, to coming back to your question, I feel like degradation of BESS is something that yes, we want to monitor, but um, I think it's not the biggest problem.
Okay, so basically, you think right now the priority should be more assess and understand how to properly adjust and control the best in I mean in regard to the to the portfolio to the PV portfolio, more concerning to the charge should behave in the market in
So
terms of yeah
exactly,
manage
yeah. So
yeah.
in some sense, like yeah, the systems software, like let's say if you have two partial discharge cycles, right? That may be equivalent to one cycle, um, but in reality, that may actually lead to a lot different kind of a very different outcome over multiple cycles like that, versus like having a charge discharge cycle of like full depth of discharge.
No, I get your point. So, what do you think? What should enterprise OM teams think about integrated monitoring for hybrid assets versus running solar and storage analytics in separate silos? Which I think some companies might do
Yeah,
that. Some company, I think, early company just implementing BESS. They're
yeah.
doing this. I'll be honest. I don't think they're into integrated hybrid system yet, which is okay. I mean, it's part of the process.
I think whether you are operating AC coupled or DC coupled, um, the monitoring should include both together. I I get it, like why one would like to look at solar individually and storage individually. But in in true sense, they're not different. Like I don't think it is very wise to look at them separately. That is what I feel. And like I'm not speaking out of lot of experience over here, but more like from what I'm seeing in my day-to-day work. One system does affect the other system. Um, and so yeah, to answer your question, they should be looked together,
Yeah, I
even if
think
it is
one of the main
complicated.
things I see, especially on BESS, it's people for we might say in different reason, not taking risk, lack of experience or knowledge. They don't automate charging and discharging. It's mostly preset. So basically, I think there are a lot of events which actually are going unnoticed and are where there is still underperformance even in this specific, I will say, process. Still, where should be. I'm talking about in terms of optimization. Because I mean, I'm not sure right now who is really listening to the grid as to which extent, who is listening to the portfolio in both regards in order to adjust the charging, charge discharge cycling schedule, which I think is where you can even stress, try to push a bit more into at the end, finally for optimizing the performance, which is the objective. Right. But I think, yeah, makes sense. It's a new technology. So I think once more adoption will lead to more data. Australia, I wrote an article, but Australia actually is what the Australia managed to deliver. I don't know right now. I don't remember how many gigawatts of BESS, but they had to rethink completely, not just from I add BESS. No, it's
Mhm.
you need to rethink from a grid perspective too, in a way to understand that it's something needs to be integrated to the grid itself. So you cannot look just, okay, I want to store, because actually if you have a grid limitation after, it will not be enough. So I think what's really fascinating in terms of market, it's a nice story for any kind of this is more for a grid operator rather than individual contributor like IPP. But I think will be interesting to adjust because wherever we see people are trying to push past portfolio are underperforming everywhere. Curtailment right now, negative prices is a common, whether it's Germany, in Europe, Spain. And we see California, I think it's a lesson because events are increasing, negative prices are increasing over a year, curtailment events are increasing year over year. So it's something that I suggest whoever is monitoring huge, where actually 1% makes a difference in terms of financial losses. It's worth looking into these dynamics to prepare for something which inevitable is going to happen. And so let's focus on the automation, Abhi. So where have you seen actually as automation generally reduce costs and improved outcomes in utility scale OM? And do you have any specific problem types or without claiming any vendor? I'm just talking really about problem, use case. What have you seen that really tomorrow? Because right now I think there is a lot of use case. Which one should I pick? I want digital twins, predictive maintenance.
Yeah, I can say one thing. I think analytics has helped a lot, for sure. There's no question in that. Especially because once you know that there's a problem, you also know now the impact of the problem, right? Impact on the energy and dollar. The automation piece is where I think there's a lot of catch up to do in the industry, because detecting a problem is more like there's an analyst, there's a software, there's an AI agent which detects that problem, but at the end of the day, there's a person who needs to go out there and fix the problem, right? And that it's not even just that the person's time is limited. It also is dictated by what is available to be fixed. So just to give you an example, if you have like a drone flyover, right? And the drone report that the company gives you a report showcasing, hey, there's 5% DC health issues that you have, which you could, if you fixed, you would get this much back. Yeah, I think that's great, but do you have enough people to do that or next week or next 2 weeks, right? Do you have the right equipment right now available in warehouse? Do you have the appropriate module bins? So all these things are like there. And I think automation is great, but it is like right now, I think, O&M needs to catch up with it.
I think it's more like you can put intelligence on an aspect, but the reality is at the end you need to play components. You need to align procurement, different departments, dispatch, side teams. So in reality, if one team is intelligence, the two are really still blind and behind. The reality in terms of outcome, you're pushing on one direction, but still not fixing the problem because the infrastructure, the company is still not optimized. This is the reality, I'll be honest, because you can invest in 200K proactive maintenance, tools, solution, millions. After, if you don't have the component, if you don't have that forecasting, because at the end there are components which are statistically inverter. You know that after a certain type of, based on temperature, based on the Celsius, which are affecting in terms of will underperform, and you can start anticipating. At this point, we have the information. The question is, do you want to be honest? Do you want to be? It's more a cultural. We discussed in this post. It's more a cultural decision too. But anyway, it's not just pushing AI. Everyone wants to implement AI. I think 50% of enterprise adoption are successful. 15. I mean, but the statistics are negative in terms of, because maybe they push a pilot, maybe they have one use case, but from one use case to an enterprise, I'm not talking for small, medium-sized company, it's easier because you are more agile. You can change fast. A CEO, we discuss with them, so they have more control. They can adjust. They can set top-down strategy, execution. For an enterprise, one decision maker, things change, lack of confidence, they don't want to take ownership, accountability. Sometimes to see results, especially on this predictive maintenance,
Yep.
takes years. Doesn't pay off in 3 weeks because now we saw maybe if you're lucky enough, your portfolio is terrible. You see things you never detected, great, good luck, it's great. But otherwise, these things will pay off over years, which sometimes is not completely aligned to the short-term financial position or quarterly financial performance of the company. So this makes sense. Where in terms of, I think this is a good important aspect we are seeing. Where does automation create false confidence? And what do you think are the failures modes that team don't talk about? Like,
Ah,
what are really the discussion people don't want to have, especially in your. I understand you have a job. Sometimes you don't want to talk neither bad about your job, your position, what you have to do. I'm not talking about you. I'm talking about as an industry.
Trust me, I do that a lot.
Yeah,
Because
good.
like yeah, when you start interacting with multiple teams, right, you get a much broader picture, and you start appreciating the overall complexities much better. I feel like, or I think it's hard to say that automation gives you a false um, impression in just one way. Um, Automation can give you a false impression of a lot of uh, different things, right? Like you may think that let us start from the very basic. When I detect a problem and I say that, okay, if you fix this problem, you're going to recover X megawatt hours. Okay. What am I really using as a reference? When I say, oh, you fix this 5 LBDs, you fix this number of trackers, you'll get X megawatt hours back in next 3 weeks, or you'll get X megawatt hours back. What am I using as a reference? Some model, right? Or maybe some other inverters as a reference. That itself is subjected to some bias. Maybe the model I was using was biased. Maybe the other inverters I'm using were underperforming. Maybe there's something wrong with my measurements, which I'm not seeing right now. So the point is, uh, those kind of like things are extremely hard to kind of do a sanity check, because yeah, like you don't know what you don't know, right? In a way. I think the second challenge I think with automation that I see is it can become very overbearing on people who are actually fixing the stuff for us. So if you kind of showcase like, hey, there are like 1,000 issues at this location, and here's a tentative plan for next 2 months, it can be extremely difficult to process. Okay, how do you really plan your day and week? So in the sense, it's kind of almost like a funnel. You're putting in lots of stuff.
You're talking for the site, for whoever is on site, so you
Uh,
have to check ideally if you share 100 more alarms, they need to go through 100 more issue. I need to spend
yeah,
more time.
exactly.
This is what you're saying.
Yeah. I think with data like QAQC, because a lot of automation is built around that, uh, there are, maybe like, let's say you have an agent which detects erroneous irradiance measurements. Okay. Now you have built that agent with certain logic, certain and it is trained to detect certain kind of issues. And you have this new sensor out there now, which is actually not having any problem, but it is under some kind of like shade between two hills. And now it is reading something different than the other rest of the power plant that it may be, that these sensors may be reading. Now your agent may start flagging it as erroneous data. I think I'm creating a very specific example. My point is, um, in some sense, anytime you automate things, you take away that um, you are essentially kind of taking away an opportunity to really think about that data, and you are kind of offloading it to the software or like that logic or agent.
No, no, I
And
get your point. I get your point. So your point is mostly in terms of this decision making, which actually is gonna happen. Someone is gonna make that decision. Either it's a system, either it's a person. The question is, did you build a system structured enough to have those doubts or reflection or information into account in order to take that? But I think this is the same. Either it's a human, either it's a system. It's both. It depends. It's on based on what how you build your knowledge. What is our internal process? Do you go through a checklist once a sensor is going down? Can be once an inverter is going down. Do you go through a specific root cause checklist to say, okay, can be this, or you skip that, you go with your set. This I think is more. I get your point, and I think it's the same with automation. You can automate process, which at the end, I mean, needs to be reliable, especially in this industry, especially with energy, especially if you work with grid. By the end, it's really how you built the knowledge and how you built the process in order to
exactly.
take into account. I agree with you, especially because I think the hardest thing about solar are so many variables, which if you don't preset, and this is what we do, and it's for us took a lot of time to do initially, but once you do it, it's way easier because at the end, you know that for every issue you have 10 root cause. And for every root cause, you have a statistical reason. We do mostly statistical, saying, okay, 87% this it's a hotspot. At 36%, this could be. For sure, after we recommend over 85, just because,
Yeah, there's a very high chance.
makes sense enough, but statistically, because the data are reliable and the process is reliable and the information makes sense. I think on your point, what you're trying to say was that, say, do you do the system, since that it's a black box, let's be honest. If you don't know the box, we try to make it more open as possible. Where you see the box, you see the granularity, you see the data reliability, because it's the main thing. Otherwise, it's without relying on the system, unreliable. Whatever it gives you, it's just you cannot trust. So, you think
So
this could be the thing?
yeah, so no, I think what the point you made is actually is what I feel should be the way forward. Automation should actually help you to think more about the results and less about like getting to the results yourself. Like once you see once you see like, yeah, here's what the system is looking like, I think you should have more time as an analyst, as somebody who's operating the asset, as somebody who's really concerned with its production, that, okay, what am I seeing over here? Okay, this is what the system is flagging, or this is what the system, sorry, I mean, the automation is telling me. Now, why is this happening? What does it really mean? So I think all those questions, you should essentially get more time to uh, think about them and to
I don't know. In
see
our
what's
cases, what
really happening.
happened at the end? At the end, because I think in order to have a system which is really, really, really smart, and for sure, I mean, once you start having your own model, we have our own model running 100 of megawatts, gigawatts, so intelligence, voltage data, different type of data from sensor too. But my point is, you still need to have rules. You still need to have an understanding of things because an
Yep.
average model would be stupid. If you plug ChatGPT in your site, it will be terrible. So I know enterprise, the best thing they do, they run their own model, they have their own, everything is proprietary, their own pipelines, if they have it, because sometimes I understand. We talk with some enterprise, they don't have that. They have
They
multiple
don't have it.
SCADA. It's a
Yeah.
mess to it's a mess. It's clear. I mean at the end, the reality is simple. What is the company's job? It's energy
Produce power.
business. So,
Yep.
no, man, they're in
Hmm.
energy. The thing is being in the what right now I see company doing, but I don't know how many that are gonna do. Some of them I understand they do in-house because it's highly strategic and makes sense. But the thing, especially when we talk, now we are automating from asset management to one, but there are a lot of functions. So the reality is you need to self-assess how much time it was gonna take to do internally everything. What will be the success rate, assuming that it's low once it's an in-house initiative? Because the reality, you have other priorities. You can even say, I want to do some AI. After 2 weeks, 3 months, other problems come up. No problems anymore. You invest resource, you invest time, you defocus. Either it's AI department, is performance analytics. I mean, maybe you can confirm this. So, no, I get your point. I think the system moving forward will be smarter, but there will be as much as the system has been structured, built, and is understanding the site. Because the reality isn't like a normal software, the plug in another software is clear. With solar, it's you plug on hardware, software, 100 variables. So if you can rely on that, it's I understand. I mean, if you need to make an investment. So last two question maybe. So if you talk about decision making on a portfolio scale, do you have any methodology you think could make sense? Or well, maybe let's focus on the challenge of inconsistent data quality, which so far today seems to be the winner of the discussion. But across mixed vintage portfolio, how do you normalize normally the performance comparison across sites with different SCADA systems, sensor, data histories, which I think is common. Either you buy once you have gigawatts, a gigawatt
I think
portfolio.
the way I approach it is, or like the team approaches, is by creating waterfalls. So of course you want to look at availability metrics and whatnot. But at the end of the day, I think what really tells the story of each and every project and the portfolio overall is the waterfall. And the waterfall essentially means how do you connect your P50 with your actual production. And sure, the waterfall is a very, I would say, very subjective thing, right? Like, different people create the waterfalls in a different way. I talk with a lot of people in the industry, and all of them have kind of slightly different take on how the waterfall should be created. But at the end of the day, every project should be connected with its P50 model using a waterfall. And in case if somebody does not know what a waterfall for solar PV would look like, it would be like you take the energy model that was used in the pro forma and then adjust the resource. If you have soiling data, you adjust the soiling and get to a weather adjusted, soiling adjusted, expected. You start going through your curtailment, inverter downtime, tracker issues, DCLs, whatnot, and try to explain all those buckets and try to quantify the megawatt hours each bucket represents, and then get to a final expected energy value, which then ideally should be close to your actual production. Usually you will end up having some delta in there.
Oh,
The,
frequently, no? All the
it is
time, all the
impossible.
time. Yeah, it's
Yes,
impossible to meet
it
the.
is. Yeah, and that's the whole point, right? The I think what I believe is the goal is never getting to 0% delta. I don't think that. I mean, that is like the North Star. So it is kind of serving me a direction. It is not, I don't think in an ideal world, sorry, in an ideal world, I will get 0%, but
Yeah,
it
for
will
this, I mean,
almost
what
never
you're
happen.
saying is the theoretical, but normally it's the
Exactly.
theoretical assumed
Exactly.
initially at the designing
Yep.
stage, in which you
Exactly.
correlate all the, the system
Yeah.
design, analytical the system design, plus
Yep.
financial estimation, all the PPA value
Yeah.
of energy of the kilowatts. So yeah, I get that, and
But
sometimes I'll be honest, I think people should even question what has been provided theoretical, because even PR, for instance.
there you go.
People said PR should be weather correlated
Yep.
to the actual each PR. We see portfolio in Saudi, it's a portfolio at a certain temperature, region, and exposure, should have a different PR theoretical compared to a portfolio in Norway, because the temperature is
Yeah.
different, the irradiance is different, even the angle where actually the irradiance, the sunlight touch the
Yes.
panel is different because it's a different part of the globe. So those things, I do not expect all the system to take this into account, even PR. And I think this is the easiest question for me to understand. What is the level of challenging your own? Because sometimes they give you data, so you say, okay, I take it. They give you a sensor parameter, a sensor result, you take it. So for me, the level is what is the level of challenge you can. How much did you stress your own data, whatever was you assume in order to say no, it's validated for as much as we said. The only thing we cannot do is everything validated 100%. I think it's impossible. But get to 90%, 95 with a good, models is way better than assuming. Sometimes I have discussion with OM director, people in industry for 20 years, and they still assume the issue once the issue is not clear from a
Oh,
technical
okay.
perspective, and can be clear if you really put the resource to make it clear.
Resources.
So we do
Yep.
that, but the thing is the gap from the average SCADA, you look into voltage data, the curve, you try to understand from whoever is the SCADA you have, what is the problem, you spend hours. Even sometimes they end up saying, I don't know. They discuss 3-4 people, they still don't know. So I think it's relevant, makes sense. So for closing, which problem do you think right now in utility scale OM are generally close to being solved with technology? And which one do you think are harder than the industry admits right now, where maybe people should even focus more?
Um, well, there's a problem which I think is partially well understood and solved, but also at the same time is having a lot of challenges. And it's the I'm assuming you're referring to PV only. So um, it's I think the module degradation. Um, uh, the module degradation is very interesting because if you take one module from the site or 20 modules, right, you ship them to the lab. It's very easy to flash test them and exactly know how much they have degraded because most of the utility scale projects do have the flash test data before the modules are put in the ground. Okay, so most of the times you would know how much these modules degraded. Also, I think there are like various ways you can use to quantify the overall degradation of the plant using statistical approaches. Um, and so from my experience, like and then of course you can throw in some uh, in situ IV tracers and sprinkle them across the site. So all these things when you combine, you get a very good picture of the module health, right? Now the problem is, so this is what I feel like is fairly understood. It is kind of like a three things you are doing simultaneously to understand the module's health. So that is, I think, great. The problem is when you do see this issue, let's say um, if you do see that okay, the modules have degraded above certain warranty level, the process from that point onwards to actually going through a warranty claim is very subjective right now. There are so many other challenges in there beyond technical level that
Yeah, it's
um,
commercial. It's it's illegal.
e-
Yeah, it's technical. You need to
exactly.
prove things. I mean, technical. You need to prove things. They will never take
Yes,
grant something
but
if you cannot prove it.
let's
It's
leave that aside. Okay, so that is definitely the big problem. But even from an energy standpoint, moving forward, if the modules are never going to be replaced, what do you really do? Do you really reduce your budget numbers? Do you start reducing your expectation, or do you always show that as a gap in your waterfall? And that's a question I've never been able to fully answer. Uh, because yeah, in some sense, if you start lowering down the budget, lowering down your expected, um, that hurts the. I mean, you'll start getting questions from the investors. On the other hand, yeah, I mean
No,
it's a
I get your
problem.
point. I think the main thing is to be aware about there are two dimensions. There is a dimension which where actually we cannot soiling.
Yep,
Soiling
yep,
you cannot just with cleaning, proactive cleaning, you cannot just even preventing hotspots. Because
yep.
soiling you can, there are certain things which are structural, which cannot design issue. They've been there. I think it's
Cannot do anything.
curtailment. Maybe you can maybe optimize later with your negative prices with BESS, which what people are doing, portfolio are doing. But the
Yeah.
thing is, I think if you are clear enough to say on these things we can take action, because proactive cleaning, monitoring can help. PID detection, hotspots. For certain, the reality, yeah, there are certain problems you can take action, so it's still worth investing. Others, I mean, you should have invested at the right time, to
Yep.
be completely
Um,
honest. So I
and
think
then like to take it one step forward, right? A lot of future looking or forward looking expectation is based on history, like historical observations, right? And I think that's where solar is no different than any other industry, right? Like in that sense, that yes, kind of history always rhymes but never repeats in a way. So if we if we if we if people say, oh, we fixed these five issues that the industry has experienced, but guess what? In fixing those five issues, you may actually open a sixth one for the new projects. And um, like to solve the, for example, to solve the uh, construction cost, right? Like to bring it down. Yeah, the industry is moving towards bigger modules. Now, I'm no module expert in any sense, but clearly we everybody knows that as you make things bigger, it is, yeah, just purely from like a basic physics standpoint, it's harder to handle these things. It's harder to kind of, I would say, first of all, install, but also if you wanted to like take them off and send it to a lab for example. So my point is, I think that's where like degradation is going to remain like a kind of a mystery
but
box.
even not just the panel, because I think the panel where people spend a lot of time, once you think what actually is failing, if you look at the inverter basically, inverter is the main cost of an actual
Yes,
portfolio, and people maybe
yes,
they don't do the accurate things, mostly are overstress because they are undersized.
100%.
So
Like
the reality that thermal stress, the temperature California,
I
desert,
know,
these things really reduce drastically by years the degradation time. So even those
I know,
components that you think, they should
and
relook
sorry, go ahead.
at the whole picture together. No, 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 man. I agree with you. I'm just saying.
I know an industry veteran who told me once, like, so he's been in the industry for 35 years, I guess, 35 years. Um, what he mentioned was very interesting, that the industry had used to have like 1,000 volt DC inverters, and right now the standard is 1,500. He has actually never seen an inverter lasting for over a decade. I think the longest he has seen is like one with like 12 years of operation. And he's just extremely critical about the industry moving towards even higher voltages. I think the latest I heard was 2,000 volts DC. And so, yeah, I yeah, I think that's where it is. I don't want to say it's a problem unsolved. It is just that there is no problem, and I think we may be actually creating one, just to like uh, beat the costs right at the
I
point.
know
And
completely. Yeah. The
yeah,
tech needs to adjust even in terms of production costs because I mean it become cheaper. People will say,
yeah,
okay, I make more,
e-
you know,
exactly. Yep,
and sell more. I have no problem that maybe they can last more because at the end it's thermal stress. So more
exactly.
you push that stress, more for sure they're you're reducing the lifespan. So last question, Abhishek, what do you think is the most well, actually, what is the single most important thing an enterprise asset manager running over 100 megawatts, 500 gigawatts portfolio should change about how they approach operational analytics today, in your experience? Maybe.
Uh, it's a tough question. I think invest in your people, honestly. And if you have people who are genuinely passionate about producing more megawatt hours, I think that's the biggest asset you can have, honestly. AI, analytics. all these things are a natural outcome of people who are curious, who want to do a good job, who want to, who are agile, but at the same time, like kind of focused on one aim, which is like, yeah, that's if we are operating 10 plants, let us make sure. So let's take a step back. Let's take all the power plants out there in this world and plot their performance, as a distribution, right? The first question you want to ask is, which quartile does your portfolio land? Is it like the bottom, the second quarter, third quarter, like the top? That's the first question. And then if you have the right people in your organization, they will naturally push your portfolio from like towards the top quartile.
I don't know completely. The question is to challenge what I see, which I think maybe some people they might not like, but if they're watching, I think they're passionate, so they're interested. So the ego, I think, in the same. You can put your ego in a plant, you know. You
Exactly.
can put. I think people put their ego in a plant. I've seen that, and I would say I'm not. I mean, we're men. Mostly, it's a men-driven industry. Let's be honest. Maybe sometimes
Yeah,
I talk with some women, but I would say 85% from OM asset man. On the OM, there are men. Asset management, there are some women, more women. I see a lot of ego in practice, in procedures, in the way of doing things. And the reality, once you look at data, the beauty of data, it's cold. So it's not like it's not emotional. It's
e-
not. It's a fact. It's a number.
exactly.
After I mean, you can question the number, the source, the reliability, whatever. But I think it's.
Yep.
And if you see you're not, I think what you said, you self-assess your portfolio. If you're underperforming, if the ideal PR, let's put the PR, no star, whatever, and the the reasonable PR, because I mean, let's not take 91 for any environment. And as you said, there are some structural problems where actually the market dimension doesn't will never push your portfolio to reach there. And there are structural, you assume that in the model, you know that you cannot work on it. On the rest, if you're still underperforming by, and I see portfolio at 75 PR, 65, like terrible. I mean, I don't know why they have a job. I'll be honest. And I'm not saying
Yeah.
whoever done things in 20 years in the same way. I get that. I'm not saying industry change, variables change. But if you are listening, learning new things, I think you need to put ego aside. Whatever you learn for 25 years is great. You learn when you have certain tools, certain knowledge. Now, the good things is there more knowledge, more tools. So I think it's someone with low ego. Intellect, curiosity can question, challenge that. Someone else will say, no, I know my job. I've done it for 20 years. I don't think no one is wrong, but just if the portfolio is underperforming, I think could be an input maybe for who is watching or listening
I
to
think curiosity beats
this.
everything,
Yeah,
honestly.
completely,
Somebody who's
completely.
curious will
I don't know,
see it through the end, honestly. Yeah.
completely.
So
But Abby, I think we are over the time. I think it's been great. Thank you for your input. Anything else you think what you feel sharing with the audience?
no, I think thanks for listening through this, and yeah, hopefully um, people find some value from our conversation. Uh, yeah, yeah, again, and thank you, Antonio, for inviting me.
I know,
This is
my
my first
pleasure.
time,
I
so
think
yeah,
interesting discussion. I think, I mean, the objective here is really to give a different perspective to people working in their
yep,
own department. Maybe they talk just
yep,
with their colleagues. They want to open a bit their perspective to see what's going on. Even other organization, you work for a big one. North America, I think you're among the what 10 top 20 biggest
yeah, yeah.
portfolio.
EDF is like
So
top 10. Yep,
yeah, top
it's
10.
it's a
So I
fairly,
think it's among the industry, I think your experience could be valuable for some people. So
yep.
thank you for
Mhm.
joining us. It was great.
Thank you.
Thank you. Bye bye.